Part 2, Steps for Graphing Rational Functions. Step 1, determine the domain. Like graphing any function, we always want to find the domain. Step 2, plot the x and y intercepts. Then plot the vertical asymptotes and the horizontal asymptote, and then other points as necessary. It says here it may be helpful to use a sign line or a number line to help us decide where the function is above the x-axis and where it's below the x-axis, and determine if the graph crosses the horizontal asymptote. There will be a few more steps coming in section 3.3, but we're going to start with this. Determine the domain of f of x equals x divided by x squared plus x minus 2. So first we need to find the domain. We know that our denominator cannot be equal to 0. So we need to try to factor that denominator if we can. So two numbers that multiply together to get -2 and add together to get 1 would be 2 and -1. So we know x cannot be -2 and x cannot be 1. In interval notation, that would look like -infinity to -2, union -2 to 1, union 1 to infinity. Next, we'll find the x and y intercepts. So the x-intercepts are where the numerator is 0, and the numerator is 0 when x equals 0. So that also gives us our y-intercept. When x is 0, we end up with 0 over -2, which is still 0. Then let's find the asymptotes. The vertical asymptotes will be where the denominator is 0. And we already found the vertical asymptotes because we already found the domain. So x cannot be -2 and x cannot be 1 is our domain. So our denominator is 0 when x is 2 and when x is -1. Those are our two vertical asymptotes. For the horizontal asymptote, we look at the degree of the numerator and denominator. The numerator has degree 1. The denominator has degree 2. So the numerator has a smaller degree, and our horizontal asymptote is y equals 0. So let's graph this rational function. So here's the things that we already talked about. The intercept at 0, 0. The vertical asymptotes at -2 and 1. And the horizontal asymptote is y equals 0. So let's graph this. We only have one point. That was the only intercept. I know I crossed that horizontal asymptote at that x-intercept, so that's the only place I cross it. I don't need to find another one. I also know that I crossed through the x-axis there because we got that x-intercept from the numerator, and that numerator, that factor in the numerator has degree 1, odd degree. So we're going to cross through the x-axis at that x-intercept. Let's find a couple of other points since we only have one point there. Let's let x equal -1 to find out what's going on between the two vertical asymptotes. So if x is -1, I end up with -1 over -1 squared plus -1 minus 2, which is -1 over 1 minus 1 minus 2, or -1 over -2, so 1/2. So -1, 1/2 is a point on my graph. I know I need to get closer to these asymptotes, and these 2 points have to connect, and I need to cross through the x-axis there. So my graph's going to look something like that. Let's pick a point to the right of the vertical asymptote. So let's pick x equals 2. If x equals 2, I have 2 divided by 2 squared plus 2 minus 2, which is 2 over 4 plus 2 minus 2, or 2/4 or 1/2. So when x is 2, y is 1/2. So I'm going to stay above that horizontal asymptote. I know I'm not going to cross it again because it is our x-axis and we only have one x-intercept. So we have to stay above the horizontal asymptote, approach the horizontal asymptote there on the right, and that vertical asymptote. So let's pick a point now to the left of the vertical asymptotes. Let's say x is -3. If x is -3, I have -3 over -3 squared plus -3 minus 2. So -3 over 9 minus 3 minus 2, or -3 over 4. So -3/4. When x is -3, I have a point -3, -3/4. I know I can't cross that horizontal asymptote still, and I know I have to approach both of these asymptotes, so my graph's going to look something like this. Now you might plot more points than I just did. I only had the intercept and then 3 other points. Plot as many points as you feel like you need to be comfortable that you have the correct graph. Let's try another one. So let's determine the domain of this function, x squared minus 2x minus 3 over x squared minus 2x minus 8. One thing you might want to do before you start is just factor everything. So our numerator will be x minus 3 and x plus 1. And our denominator is going to be x minus 4 and x plus 2. So our domain, we know x cannot be 4 or negative 2 because that's what makes our denominator equal to 0. In interval notation, that looks like negative infinity to negative 2, union negative 2 to 4, union 4 to infinity. Next, we'll find the x and y intercepts. So the x-intercepts are where the numerator is 0. So our x-intercepts are where either x plus 3 equals 0 or x plus 1 equals 0. So x equals 3 and x equals negative 1. So my x-intercepts are the point 3, 0 and negative 1, 0. Then the y-intercepts are where x is 0. So if I put in 0 for all the x's, I'm left with 0 squared minus 2 times 0 minus 3 over 0 squared minus 2 times 0 minus 8, which is 3/8. So the y-intercept is the point 0, 3/8. Now let's find the asymptotes. So again, factored, we had x minus 3, x plus 1 over x minus 4, x plus 2. So the vertical asymptotes will be the lines x equals 4 and x equals negative 2. And for the horizontal asymptote, I'm going to go back to the unfactored version of my function. The numerator and denominator have the same degree, so the leading coefficients are 1 over 1. So the line y equals 1 over 1, or 1 is my horizontal asymptote. Let's also check if we are going to intersect the horizontal asymptote. So it does x squared minus 2x minus 3 over x squared minus 2x minus 8 ever equal 1. My horizontal asymptote is 1. Multiply both sides by that denominator, and I get x squared minus 2x minus 3 equals 1 times x squared minus 2x minus 8. Subtract x squared from both sides, add 2x to both sides, and we get negative 3 equals negative 8, which is not true, so we do not cross the horizontal asymptote. Let's graph. Here are all the things we found. The intercepts at 3, 0, negative 1, 0, and 0, 3/8. A vertical asymptote at x equals negative 2 and x equals negative 4, and a horizontal asymptote at y equals 1. So here are those intercepts, and here are the asymptotes. I do know I'm going to cross through the x-axis of both those intercepts. My numerator was x minus 3 times x plus 1, and both of those factors were degree 1, odd degree, so we are going to cross through, and these points all need to connect. So my graph will look something like that in between the two vertical asymptotes. Let's pick a point to the right of the vertical asymptotes to find what's going to happen on the right side. So let's pick x equals 5. If x equals 5, I have 5 squared minus 2 times 5 minus 3 over 5 squared minus 2 times 5 minus 8, which is 25 minus 10 minus 3 over 25 minus 10 minus 8, which would be 12 over 7. So when x is 5, y is 12/7, which is not quite 2, so about right here. And I know I'm not going to cross that horizontal asymptote, but I do need to approach that and the vertical asymptote. So the right side, this is what my graph will look like. On the left side, let's pick x is negative 3. Then I would have negative 3 squared minus 2 times negative 3 minus 3 over negative 3 squared minus 2 times negative 3 minus 8. So 9 plus 6 minus 3 over 9 plus 6 minus 8, which is 12 over 7. So again, 12/7, about right here. And my graph's going to look something like this.